This is Geometry, Lesson 9-1, Solid Figures, Identifying Volume and Area. Our objective today is to know the names of solid figures and find their volume and surface area. So that is a lot to do all in one lesson. This is a larger than a typical lesson for my class. The first thing that I want to start off with is how to find areas of basic shapes. This will help us to find the surface area and the volume. So I'm going to start with the very base knowledge of a rectangle. Remember that rectangles define what it means to multiply. If I had 2 by 3, 2 times 3 is 6 because it's 2 rows of 3 columns and you just multiply. So a rectangle is just multiplication where you multiply base times height. So my answer for our area is just multiply B and H. You don't have to have a little dot in between, but you can if you want. Okay, what about a triangle? So a lot of students, when they first find the area of a triangle, they just have a formula. I want to talk about a little bit more where that formula comes from. So if I were to make a triangle that has the same exact base as this rectangle, but I can move this tip of the triangle literally anywhere. I can even move it all the way out here, but as long as it's the exact height of this rectangle, it doesn't really matter. I'm just going to randomly choose right here. If I were to cut this in half, you can clearly see that. Let me go ahead and highlight this. There's clearly a red part on the inside here, and then there is a non-red part, and it's cut in half. This red and this white are equal size pieces. Similarly, if I were to color in this right side of the triangle, you can see that this right side of the triangle and this right side of the triangle, the red versus the white are 2 equal pieces, which means this red is always going to be half of the triangle, or half of the rectangle rather. So this rectangle I'm half of, this rectangle I'm half of, therefore I'm half of the entire rectangle. So essentially you take the formula for our rectangle, base times height, so BH, and then you take half of that. So you can say 1/2 out front if you want, or some people just say you just divide it by 2. That's also fine. I kind of like 1/2 base times height. And then we use triangles to define a lot more shapes like pentagons, hexagons, septagons, etc. Another thing that's helpful to know, while we don't have any parallelograms in today's lesson, they do help define what a trapezoid is, so it's worthwhile knowing where a parallelogram comes from. In general, everything, we always try to get back to basic multiplication. So is there any way to turn a parallelogram into a rectangle? And the idea is, what if we were to cut right here and move this piece over here? What would that look like? It would look like moving this piece over here, and then all of a sudden I would have this red rectangle where this base over here is the same base that I started with, and this height is the same height that I started with, and it's just base times height. It's kind of cool that you can just move that piece over and it turns into a rectangle, therefore it's just the rectangle formula. So again, that is a parallelogram, and if I come backwards here a little bit, this is a parallelogram is base times height, where this is the base and this is the height. Okay, and I should be careful here. I have to say this exact distance from here to here is the height. I don't want you to think that this length right here is the height. It's not some diagonal. It always has to be a 90-degree angle to this base, otherwise it doesn't work. All right, and finally, trapezoid. How are we going to turn a trapezoid into a rectangle? That's the trick. And usually I let students try to do this a little bit more in class, but I'm going to tell you directly because I have a lot of knowledge to get through today. So the way that I'm going to do a trapezoid is I'm going to copy this exact same trapezoid. So I'm going to grab this trapezoid, I'm going to copy it, and I'm going to paste it. So the problem with this is I have 2 trapezoids. So my very last step will be 2 divided by 2. But I can find the area of these 2 trapezoids really well if I rotate this. And I want to rotate this and keep it the same size. Hopefully I kept it the same size. It looks like I made it a little bit too big. If I keep it the exact same size, you can see, make it a little bit bigger, come on. A little bit bigger, there we go. If I make it the exact same size, you can see that it perfectly matches up onto, well, it should match up, it's a little bit off down here. It should perfectly make a parallelogram. You can see that this, if I were to ignore it, is now a parallelogram, and we know how to do a parallelogram. The way I do a parallelogram is I grab U and I bring it over here, and it turns it into a rectangle. So essentially, what I had was, I had 2 different lengths, right? So usually we call this length down here, that's one of the bases. This is also a base, but they're different bases. So we'll call one base 1 and base 2. If this tiny base 2 up here is that length base 2. This length also right here is base 2. And to find this entire length, you just add the base 1, base 2. You say b1 plus b2. You add both the big and the small, and that's the entire length. And you just multiply it by the height. And we're going to say that this length right here is the height. So this entire thing times the height is the exact area of this parallelogram. Of course, there is the problem that there are two trapezoids. There's trapezoid 1, trapezoid 2. I made a copy, so I have to divide by 2 and get rid of that second trapezoid. So I have to divide this whole thing by 2. But that's where the formula for our trapezoid comes from. You have to add them, add the top and the bottom, and then multiply it by the height, and then divide by 2. Another way of interpreting this formula, by the way, if you're curious, is you take the average of these two values, the average of these two, you add them and divide by 2. It's that number right there is the average of the two bases, and then multiply it by the height. All right, and then pentagon. That's kind of a fun one too. Whenever you get these larger shapes, essentially what we're going to do is we're going to turn this into triangles. So here's how I'm going to see this triangle. You always start from the center, and you see the triangle come out to the sides. And essentially, you're looking for that exact shape. So we have this exact shape like right here, where we had this black bottom and dashed line. So this is the triangle that I'm looking at. And you can see that there are a total of 1, 2, 3, 4, 5 of those triangles on the inside. And all of those triangles are congruent. It's the same triangle right here. So I just need to find the base and then the height here. That's going to be the height. And then to find the area of this one triangle is base times height. And then you have to do 1/2 of that, or divided by 2. And how many of those do we have? Well, this pent word is a kind of a giveaway. Pent means 5. So I'm going to do 5 of those triangles, which we already know how to find from our notes up here where we found the area of a triangle. And then finally, the hexagon. It's not finally because we have a circle, but next the hexagon is very similar, where you can see that we're going to cut this into triangles again. And if I look at that triangle, so I have those red pieces here, I have this black piece here, I have that height here, where this is the height and this is the base down here. Again, the area of a triangle is 1/2 of the base times the height. And then how many of these triangles we have? We have, if we cut them all into pieces, we have 1, 2, 3, 4, 5, 6, which makes sense because hex means 6. So I just multiply 6 by the number of triangles that I have. I can find the area of each of those triangles very easily. The one that's the hardest for all of geometry to prove, I think you need calculus actually in order to prove it, is the area of a formula. Most people learn the area of the formula like when they're in 7th or 8th grade, sometimes earlier. The area of a circle, you have to use a constant called pi. It's going to be pi r squared. It's a little bit different than the circumference, but we're not doing circumference yet. I might as well just add it on here because I think that's helpful to know. The circumference of the circle is 2 pi r, and circumference is the distance. If I were to be an ant and I walked on the outside of that circle and I walked all the way around, how far would I have walked? I would have walked the circumference. And notice that you're using the same numbers, pi r2, pi r2. They're just in a different order. Excellent. This actually will come in handy when we're starting to talk about cylinders. All right, so I talked a lot about areas. You now know how to do areas and circumference for all of these basic shapes now. Now I want to start learning some new stuff, some names. So I'm going to first talk about prisms. Basically, in this lesson, you're doing prisms, pyramids, and then circle-y things. So prisms, we have two faces that are congruent, the two faces that are the same, and we connect them with parallel lines. So I copied this shape, and I'm just going to connect it with parallel lines. You can see that this line goes to this line goes to this line, please, and this line goes to this line, and you can see that I have a prism. Because the faces here, the base here, I can maybe shade in the base so you can see it a little bit better. But this base right here was a triangle. Then you call this a triangular prism. So I'll say triangular prism. And then what if I start with squares? Again, I copy these squares, and I can just connect all of these with straight lines, straight lines, straight lines. If you have a square prism, then that's sometimes, it's not necessarily a cube because these lengths right here aren't always the same as these lengths, but this is still called a square prism because the base shapes are squares. And then connecting the lines of our rectangles. You can probably already tell the name. I hope that you're guessing before I'm even saying it. I just like making sure that they're all drawn for you guys. This is going to be a rectangular prism. Rectangular prism. Do you remember the name of this shape? We went over it already. So this line, I guess they go here. Let me go ahead and move one of these so it looks a little bit cooler. Move this right here. So if I move, yeah, that looks better. So just connecting all of the vertices, and we can see we again have a prism, and this is a trapezoidal. So trapezoidal prism, and then these are pentagons. Pent mean 5-sided shape, and luckily these all snap together. It's kind of nice, and like so. So that is a pentagonal, or pentagonal. Pentagonal is, I think, how it's pronounced, but you can say pentagonal as well. And then if they're hexagons, let's go ahead and connect. Ooh, this goes right here. I messed up. This goes here. There we go. See our shape. They do snap quite nicely in this program that I'm using, GoodNotes. And this is a hexagonal. Hexagon, and then you just add the AL, hexagonal. So make sure you know how to spell hexagon, and then you can add the AL, how to spell pentagon, and then add the AL, trapezoid, add the AL, rectangle. We switched it a little bit, but they're very, very similar. So those are all the prisms that you need to know. And then pyramids are very similar, so as long as you have your base shape, hey, look, this one is a triangle, well, then this one is a square, etc. Like, I had to draw these in a slightly different perspective to make these look cooler. But essentially, you might be more familiar with the square pyramid. So the square pyramid looks like this, right? You connect. Whoa, I want a straight line though. Straight lines, and this point is in theory supposed to be directly in the center, but that's not always the case. So if I just connect all these vertices up. This is called just, you don't call these just a pyramid. This is a square pyramid. Square pyramid. And this is a triangular pyramid. And this is if it's a rectangle on the bottom. I know it kind of looks like a parallelogram, but that's because I had to draw it with perspective. Not the best picture, but there it is. Oops. It wants to curve that one. This one is going to be rectangular. Rectangular. And instead of all of the lines being parallel, they all meet up at a point. So you can already take a guess on what this next one is going to be. This one has a pentagon for a base. So this is that one didn't work very well, but we're going to go pentagonal pyramid. And then hexagon. Again, you probably already know this one because it's the same word as up above. This one is going to be hexagonal pyramid. That one was slightly curved, that's okay. We're going to connect all those, and we have a hexagonal pyramid. Cool. And then finally, we have the shapes that are based on circles. So again, this one's kind of like a prism. I think the official definition of a prism is that you have to have polygons. Technically, polygons can't have any curves, and circles are curves, so this technically is not a prism, but it follows the rules of a prism, right? They're parallel in two shapes. This one is very similar to a pyramid because, again, you all meet at a point, and then I guess I should name these, shouldn't I? This is called a cylinder. This one is called a cone, like an ice cream cone, right? And then, or traffic cone, perhaps. And then this one is a sphere. So the way that I do a sphere is I turn my paper 90 degrees, and I draw like this circle on the inside to make it look 3D, and I can do like a dashed line in the background to make it really look 3D. And now you can see that one is a sphere. So I'll type this one. Sphere. All right, so that's the first of my 3 objectives. Do you know all of these names? And there are a lot of names. These are your basic solids. There are so many geometric solids that you can memorize. I just want you to have these down for geometry for high school. I think we've advanced beyond just doing pyramid. Now that there's multiple different types of pyramid, right? All right, so time to talk about the second of the 3 objectives. How do you find volume? And it's actually easy if you know the areas. So let's go ahead and assume I can find each of the areas that was up above, right? We know how to do rectangle, triangle, trapezoid, pentagon, hexagon, and how to find circles. Everything about volume is based on that area. So what you do is you take the area of your base shape. In this case, the base shape is this triangle down here. So I'm going to call this B for the base. You take the base shape, so I'll say the volume here. The volume is always going to be the base shape area times the height. So B, I'm titling for the base area. If you take the base area and you multiply by the height, done. That's a prism. So again, it doesn't matter if the base area is a triangle, a hexagon, a pentagon, a trapezoid, it doesn't matter. It could even be a circle, right? So I can say the base area here for this circle is capital B. You just multiply it by the height. So you say, oh, well, this technically you have a bunch of formulas to memorize. This is pi r squared because it's a circle, and then you slap on an h on here. You always multiply the h by whatever the area is. Oh, this one is 1/2 base times height, and then times height again, so it's actually height squared. There's a bunch of formulas, but this is the easiest one to memorize. Take the base area, multiply by the height, over and over again. And I do have a demonstration in class for the relationship between a prism and a pyramid. And it's really cool, but for now, because I'm just on the digital notes, you're going to have to trust me on this. The pyramid, it's the same idea. The core idea is you take the base area down here, which we're going to call B, or this base area down here, which it could be a circle. It doesn't matter, again, what the base is exactly, what shape, but it's the base area. So the volume is going to be the base area. This is the base area. And we multiply it by the height, which is exactly the same. And then we take all of that and divide it by 3, 1/3 of that. If you take 3 of these triangular pyramids, it will turn into a triangular prism. If they have the same height and the same base, and you put 3 of these together, they will exactly be the same thing with a prism. I don't know exactly how to prove it with the circle one, but I can prove it for all the hexagons, all the ones that have no curves. All right, and then finally there's the weirdo. Sorry, spheres, but you're the weirdos. There isn't any nice way to remember surface area or volume for spheres. I sometimes forget and I have to Google it. Hopefully I still have this right. But the surface area, I'm going to call S for surface area of a sphere, is 4 pi r squared. I just have it memorized for now. And then the volume of a sphere is, again, kind of weirdo. The volume is going to be 4/3 pi r cubed. Again, in both of these formulas, I'm assuming that r is the radius of the sphere, the distance from the point to any of the outsides. Just as a small note that's not that important, a sphere is different than a ball. A sphere literally means the outside part of that ball. It doesn't mean that the ball is filled in. A sphere is hollow. Always a sphere is hollow. If you're talking about something that is filled in that is also a sphere, you're really talking about a ball. A sphere is always going to be empty inside. All right. So we've done a bunch of learning, but we haven't applied anything. We haven't even talked about how to do surface area really yet. I've just showed you a bunch of fancy formulas. So let's do 2 examples, and then you guys can start on the homework, which is kind of long. I've given you every possible shape for the first few questions, and then I give you some volume questions, and then some surface area questions. So I've given you 30 questions. It's a really big assignment today. You guys can do this, though, because you guys are pretty bright. So in number 1, we want to find surface area first. And when we find the surface area, a lot of those numbers are going to help us discover what the volume is. So the first thing that I'm seeing for the surface area is that there's this really hard shape, this trapezoid shape right here that I want to deal with first. So I'm going to redraw it because that's my strategy. I'm going to say, okay, there's going to be this shape that looks kind of like this. It's called a trapezoid. And I don't know exactly what the lengths are, but I can say, okay, this looks like it's a height at 3.5. I'm going to do units at the very end. I'm going to ignore units right now. That length is 3. And I don't know what this length is. Ooh, this length right here is, but I can see that that length was 7 up here. And that length seems to be preserved over here. So this length is also 7. I'll say that length is 7. And I happen to know that the way that you find the the area of a trapezoid is you add these two base numbers together, the ones that are parallel. So I'm going to add 7 and 3, and then I'm going to multiply that by the height times 3.5, and then I'm going to divide everything by 2. So the area of this one is going to be, maybe I should do an equal to sign here. The area of this is going to be 10 times 3.5 all divided by 2. And then 10 times 3.5 is, you just move the decimal place, right? So it's going to be 35. So this is going to be equal to 35 over 2. And 36 divided by 2 is 18. So this is a little bit less than that, 17.5. So I know that this area here is 17.5. I just have to find the area of each of these, what are called faces. So I have the area of this face, it's 17, I should write it down, 17.5. And because these bases have to be the same, the faces are the bases in this case, they have to be the same. This one back here is also a 17.5. The only thing that's left over is to find what is the area of these rectangles that are connecting them. So this individual rectangle right here, I would like to redraw. So it seems that I have a rectangle that looks like this. And this one is going to be 4 on this side, and I need to figure out this length up here. And that's going to be the same thing as 8, so I'm going to say 4 times 8. And rectangles are nice and easy. You just multiply. 8 times 4 is 32. And it looks like I'm trying to find this rectangle next. I'm going to do this one on the bottom. So that rectangle, again, I'm redrawing each of these pieces so I don't make a mistake. It is a little bit of work. Usually students are better at this, at visualizing these shapes in their head. I see a length of 3, so I'm going to label that 3. And I need this length right here. Again, that length is always 8. These lengths are all 8. They all have to be the same length. So that's a cool little hint. So it's going to be a 3 and 8. 3 times 8 is 24. Okay, what about this rectangle over on this side? Well, that rectangle is not super clear. Okay. I see that there's this little tick mark back here and a tick mark right here. If this tick mark is this tick mark, which is this tick mark, it already told us that's 4 miles, which means it's another 8 by 4, which means I have this one. So I have 2 of that shape. I have 2 of that shape. And the only thing, this area and this area down here are 2 different areas. So there's only one of you, and there's going to be the only left over area that I have is this area right here. I'll go ahead and redraw that rectangle over off on the side. Okay, that rectangle, it is definitely 8 for one of the sides, 8, and 7 is going to be the other side. So it's going to be 56. All right, so what's the running total that I have? I have, this is totally calculator enabled, so go for it if you want. I prefer not doing it with a calculator, so I'm going to do surface area calculation right here, SA for surface area, or you can just do S for surface area, it's fine too. What do we have? We have a 17.5, another 17.5, because we have 2 of these trapezoids. We had 2 of these 32s. I'm just going to do that in my head. 2 times 32 is 64, so I'm going to add 64. I had 1 of these 24s, so plus 24, and I had 1 of those 56, and I have all of them, right? 1 of those 56. Again, asking for surface area is the equivalent of asking, hey, I need to paint this thing. How much paint do I need? All right, so I need to grab all this and move it up a little bit. Right there is a good place. All right, so I'm going to carry my 1 already because my 0.5 and my 0.5. So I know that I'm going to end in 0.0. What do we have here? 7 and 8. 8 and 7 is 15. 15 and 4 is 19. 19 and 4 is 23. 23 and 6 is 29. So I'm going to say 29. And then I'm saying 2 plus 1 is 3, plus 1 is 4, plus 6 is 10, plus 2 is 12, plus plus 5 is 17, so 17. And there's my final answer. It's going to be 179. And this is the point where we get to units, which I haven't talked about in the notes that much. But whenever you have volume, it's always a unit to the power of 3 because it's in the third dimension. And whenever I have area, it's the power of 2 because area is in the second dimension. So it's going to be 179 of the same unit down here. These will always be the same unit. You never have to convert miles. And because it's area, this is going to be the power of 2. It's in the second dimension, miles squared. So that's the first of the two questions. The next question is asking about the volume. The volume is going to be the area of the base shape. So we already found the base shape. I'll write this out for us. So the volume is going to be the base shape times the height. We know the base shape is 17.5, and we know the height is 8. So the way that I multiply by 8 is it's a double, double, double. And 2 times 2 times 2 is 8. So that's how I'm going to try to do this one in my head. So 17 doubled is 34. 0.5 doubled is 1. So 34 plus 1 is 35. So 35 is my first double. So this is really it doubles to 35. And I double it again to 70. And I double it again to 140. And there's my answer. My answer is going to be 140 of my correct unit, in this case, miles. And then this is the third dimension, so it's going to be to the power of 3, 140 miles cubed. Excellent. And you can see how easy volume is when you have all the numbers already done from surface area. All right, example number 2. We have to find the surface area and volume of this shape. So this case, I have another of these prisms, so I have a bit of work to do. If I had a pyramid, I'm realizing that maybe I should have taken a pyramid. Do I have a pyramid I could add? I do not. So if I had a pyramid, these shapes, instead of being rectangles, they would be triangles. But I think that's still easy for you guys to figure out. I think the main thing in this one that most students are struggling with is how do you figure out the base shape of this pentagon down here? Because I didn't analyze this up above, but the shape that we were dealing with was called a trapezoidal prism. Trapezoidal prism. You should know how to name each of these. And this one down here is a hexagonal prism. So hexagonal prism. All right, so let's go ahead and dissect this thing. So for this one, I'm going to try my best to draw a pentagon, although I'm not the world's best artist. There's my best way of doing a pentagon. Maybe you can do one better. All right, so what do we know about this pentagon? It has a center, and it has this dashed line coming down that is 4.1 yards long. And I happen to know that every single one of these lengths is the same, and therefore every single one of these lengths are the same. So this length down here is the same as this length up here, which is 6 yards. So this distance from here to here is 6. And again, the way that I deal with this problem is I make this into a triangle, and I can say that triangle is this triangle right here, which I'm going to redraw. This triangle is a height of 4.1 and a base of 6. And to find any triangle, it's always going to be, so the triangle is equal to 1/2 of the base times the height, 4.1. 1/2 of 6 is 3, so this is really equal to 3 times 4.1, which is equal to 12.3. All right, so we have one of those triangles done. And how many triangles do we have? You can just divide up really quickly. You have 1, 2, 3, 4, 5 of them, which makes sense because this is a pentagon, meaning 5. So now I have to multiply this by 5. Well, I know 5 times 12 is 60, so this is going to be 61.5 because 5 times 3 is 15, so there's where the 15 came from with the original 60, right? So 61.5 is the area of this pentagon. So I can maybe just label this as a 61.5 here so I can remember that. And I know that the top and bottom are both 61.5. So if I'm doing my surface area calculation, we have to add up all of these. I have a 61.5, another 61.5, and then I have to find each of these. So the lucky thing about most prisms is these, they're called lateral faces, the ones that are on kind of the outside. The lateral faces are all congruent on prisms. So I'm going to draw just one of these rectangles, and we don't have to do it more than that. We we can say this had a height of 8. We know because these tick marks are all the same, this tick mark is 6 and the height there is 8. So we can say this is 6 by 8, which is 48. And how many do we have? Well, there's 1, 2, 3, 4, 5 sides. So this is multiplied by 5, right? So 48 times 5 is going to be 240. How I did that in my head is 5 times 8 is 40. So that's 40. And 5 times 4, you half it. Or I guess I half the 4 and then put 2 zeros, but I don't think that's the best way of doing it. It still works. 240. Anyway, so we have 240 surface area from that, and we have 2 of these 61.5. So if I'm adding up all of these, I have, here, let me show my work. I have 5 times 48. That's what I'm really adding here. This is going to turn into, if I double 61.5, I have 123. 5 times 48, I already said, was 240. So I'm really just adding these together, and I get 363. So my final answer is going to be 363 units, which in this case are yards. And we're in the second dimension, so it's going to be yards squared. Excellent. So that's my surface area. And now it's time to do my volume. Volume is going to be equal to the base area times the height. The base area, in this case, we already know, is equal to 61.5, and I just need to multiply that by 8. And another multiply by 8. Interesting that I picked 2 of those. I didn't even realize that. So multiply by 8 is a double, double, double. So let's double this once. So to get from here to here, just multiply by 2. That's going to be 123. Double it by 2 again. It's going to be 246. 46 doubled is 92, right? 92, and double the 2 is 4, so 492 when I, so this is double, double, double. So I should get 492, and then our units in this case are yards. So YD for yards, and then we're in the third dimension because we're in volume, so yards cubed for my answer. All right, I realize that maybe in the future I can choose a better example. Maybe I'll do a pyramid or something in the future so I can take 1/3 of this answer, because essentially a pyramid, you do all this work and then at the very end, then you divide by 3 for the volume. And for the surface area, instead of having rectangles over and over, you'll have triangles over and over. All right, well, that was a long enough note, so there's a lot of material for you guys to cover. Try your best to finish in class, and I'll see you guys later. Thanks for watching.